Before I teach you how to solve these kinematic problems in one dimension, we're going to have a quick review. If those two vectors describe your motion, are you moving up or are you moving down? Shout it out. Down. That's what the velocity vector tells you. And are you speeding up or are you slowing down? Slowing down. They're in opposite direction. Now, the piece that some of you are missing is, if this is your velocity vector at noon, what would your velocity vector look like at 1 second after noon? Okay? Well, that's what the acceleration is. It's the change that happens in 1 second. So what I would do is I'd stack that there. There's the plus sign there. And your velocity vector would be that much shorter. 1 second later, it would be that much shorter. 1 second later, it would be that much shorter. 1 second later, that much shorter. 1 second later, it would be 0, but only for an instant, because you still have that same acceleration, so now you would be moving up. Now, how could I have that kind of motion? Well, have any of you bungee jumped? I did. Oh, good. This is a sensible class. No one here is bungee jumping. Good. Okay. We're going to review by looking at a bungee jump. And I've got a handout here. One of my younger brothers, Kenny, he and his friends would sandbag. And you sandbag off of a bridge over a narrow ravine with a river below. And what happens is you and your friend, you stand on the edge of the bridge and you hug each other and then jump off. Now only one of you is tied to the bungee cord, so one of you is hugging tighter than the other. When you get to the bottom, when you get the closest you're going to get to the river, you drop your friend into the river, and that catapults you back up towards the bridge. And the whole point of sandbagging is to miss the bridge on your way up. I didn't say it was a smart thing to do, I just said my brother did it. My mother, bless her heart, never found out while she was alive. We kept it pretty hush-hush. Okay, in this bungee jump, we've broken it up into 7 motions, but not all of the motions are motions. For example, motion number 1, you're just standing there looking over the edge. And you haven't moved for about 30 minutes. And you're not going to move for another 10 minutes. You're just looking over the edge, people are behind you yelling, and the only thing moving are your knees, and they're shaking. Okay? Motion 2, you finally get up the courage to step off. Motion 3, you're heading down towards the river, and the bungee cord is slowing you as you move towards the river. Motion 4, you're at the turnaround point. You're at the closest point to the river you're ever going to get. If you were sandbagging, you'd drop your friend, but you're not. It's just you. Motion 5, you're speeding back up towards the platform. Motion 6, you're still going up, but now the bungee cord is slack. And motion 7, you're at a turnaround point. You're about to go down and bounce again for free. The first time costs money. The second time is free. Okay? So now what we'd like you to do is for each of those motions, give a velocity vector and an acceleration vector. Now folks, all I want here are the directions of the vectors. I don't care about the magnitudes. Just is it up, is it down? If it's 0, put a dot. Just put a dot. So with your neighbor, quickly fill this out. It's review. It should be like a Rorschach test. Can you see the butterfly? Okay? Okay, again, this is review, and it should have been quick. Let's go over the answers. At 1, do you have a velocity? Do you have an acceleration? No. Okay? So that would be 0 and 0. And I know I don't have an acceleration because acceleration is how much my velocity is going to change in the next second. And it's not going to change for another 10 minutes. Okay? So that's 0. Now at 1, my velocity is up, down, or 0?
Down.
I'm sorry, at 2.
Down.
Down. I'm moving down. And I'm speeding up, so my acceleration would be down. At 3, I'm moving down, so my velocity is down, but I'm slowing down, so my acceleration is up. At 4, I have to stop to turn around, so my velocity is 0. Is my acceleration 0 there?
No.
If it was, I'd just dangle there. I wouldn't bounce. My acceleration has to be up. I was going down, I will be going up. That's a change in the upward direction. In motion 5, I'm moving up, so my velocity vector's up. I'm slowing, no, I'm still speeding up there. So my acceleration would be in the same direction of the velocity, up. It's at 6 that I'm moving up and slowing down. So there the velocity would be up, but the acceleration would be down. At 7, I'm at a turnaround point. I have to stop to turn around. My acceleration is down. I was going up. I will be going down. That's a change in the downward direction. Check that your neighbor has all of those answers correct. Now, I've noticed that many of you, by that I mean most of you, have not yet gone to check out the homework solutions. And so I didn't want to waste the back of this sheet, so I put the solution for one of the problems that was due today, hoping that you would at least see the solution to one of the graphing problems. I don't want you coming to the midterm not ready to solve one of these graphing problems. Okay? So bungee jumping is the most fun you'll never want to have again.